Okay, this is the example. If you remember that the VP of sales of Chicago Connection Sandwich Company is interested to testing whether the 4 locations generate orders of equal dollar value or no. The null hypothesis, whether they are the orders they have equal dollar value or no. We said that we have 4 populations, right? And these are the levels. We call them the levels. The factor, we have only one factor, which is the location, right? And we have different 4 locations, and we call these locations, the different 4 locations, we call them levels or populations. So I'm going to take these to Minitab, copy paste. Then I'm going to go to basic statistics, no, ANOVA, One Way ANOVA. Then we are going to choose the second option because every factor level exists in one column, right? They are not all of them in one column. They are separated in different columns. So I'm going to select we have 3. We should have 4, but I forgot to copy the 4th one, so let me do it here. Okay, so let's go to ANOVA, One Way. Again, we have separated column, so we're going to select the first 4. We're going to go to options. We're going to assume equal variances, and the confidence level is 95%. The type of the confidence interval, let's keep it 2-sided. Comparison, we will be using 2 keys later, but now let's leave it. Graphs, if you'd like to have graphs, that's fine. For the residual, the error, or for the data, you can do the box plot as well if you'd like. For the results, all of them are selected. We care about analysis of variance. Okay, now we got these outputs. The method that we are assuming all means are equal. This is the null hypothesis. mu1 is equal to mu2 is equal to mu3 is equal to mu4. The alternative hypothesis that not all of them are equal, at least 2 of them are different. Significance level is alpha equals 0.05. How many levels do we have? We have 4 levels. 1, 2, 3, 4. 1, 2, 3, 4. 4 levels, 4 populations. We have 1 factor, which is the location, right? This is the analysis of variance. This is the SS. This is the factor. This is the SSB. Sum of the squares between samples, 22. Sum of the squares within samples, or sum of the squares of the error, right? If you add these 2 values, you get the total SST, 22088. Degree of freedom, which is how many groups we have, how many levels we have. We have 4. 4 minus 1 is 3. Then the degree of freedom for the error is the sample size, all of them, the sum of all of the sample size minus k. We have 32 minus 4, which is 28. If you add these 2, you get 31. Then the MMS, the mean of these, you just divide 22 over 3, we get this number. Then if you divide this number by that one, we get 7.1. If you divide 198.88 divided by 28, you get 7.103. Then we calculate the F value. The F value is you divide these 2 values. 7.33 divided by 7.103. What we get 1.03. What is the p-value? The p-value is greater than the alpha, right? So the region is bigger than the alpha, so we fail to reject. We fail to reject the null hypothesis because the p-value is way greater than the alpha value, which is the confidence level. And as we said, there is no sufficient evidence to conclude that any of the 4 locations will generate higher average dollar lunch orders than any of the other locations. This is the conclusion because we fail to reject the null hypothesis. So it's kind of, we don't have evidence to say they are 2, at least 2 of them are different. So we still have the assumption that they are all equal, right? We could not prove otherwise. And if you'd like to look at the mean and the confidence level, you can look at the confidence intervals for each population. Also, you can look at the data, how the data are. These are the same, by the way. These are the box plots for each population. You can look at the mean. You can look at the distribution for the sample. If you'd like to get okay, let me go back here. This is the F test. What if I would like to get the F critical? Let me just pause this a little bit. So this is the F test. What if you would like to know the F critical? The F critical. If you'd like to compare the F test by the F critical. Now we compared the p-value with alpha. The p-value with alpha is clear because alpha is 0.05. P-value is greater than 0.05, so that's why we failed to reject. So it's not in the rejection region. The F test is not in the rejection region. So how to compare it with F critical? Okay, to get F critical, we go to calculations, probability distributions, then we go to inverse cumulative distribution function, then we choose the single value. Because alpha is 0.05 and the F value, it's gonna be on the right tail, so we look at the left region. The left region is 1 minus alpha, which is 95%. If alpha 1%, this value is gonna be 99%, and so on. The distribution, we have to choose the F distribution. The numerator degree of freedom, which is a 3, is 28. How did we get 3 and 28? From here. If you remember, we divide this one over this one to get the F value. What is the degree of freedom of this value? Is a 3. What is the degree of freedom of that one? Is 28. So 3, 28, numerator, denominator. Then we do okay. We get this is my F critical, which is 2.946. It's about 2.95. This is the critical value of the F. This is F critical, which is greater than 1.03. So our test value is less than the critical value. And if we go back to, where is chapter 12? If we go back to this, we can see them here. This is the 2.95, the critical value. This is the rejection region, which is alpha 0.05. This is my test value, the ratio. It's located here. It's not in the rejection region. And from here to up there, it's my rejection. It's my p-value. So where is my p-value? It's from this line up to the right, the whole thing, which is 0.3. What we got? 0.39, 40%, approximately 40%. This area is 40%, which is greater than 5%. Makes sense? So this is the whole thing about this example. I'm going to give another example next.